Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve some minimization problems. Here we have to find the minimum values of these expressions. For the first one we have some radical expressions of x, and for the second one we have some radical expressions of x and y. Here x and y can have real values. Now the interesting aspect of this video is, I am not going to use any calculus to find their minimum values, because this problem can be approached from a different perspective. What I am going to do here is to think about the geometric interpretation of the problem. What does each expression mean in terms of geometry? For example, for the first problem, let this expression be function f(x). Now let us complete the square inside each radical. For the first one, if we split 13 into 9 plus 4, then this x squared plus 6x plus 9 gives the perfect square. For the second one, x squared minus 8x plus 16 gives the perfect square, so we split 17 into 16 plus 1. So this part is perfect square, so we have square root of first x plus 3 squared, and let's write plus 4 as plus 2 squared, and then square root of now x minus 4 squared, and let's write plus 1 as plus 1 squared. Now on the xy plane, take points A, which is minus 3, 2, B, which is 4, 1, and P, which is x, 0. Here, this P is the point on the x-axis whose position changes as x changes. Then you can easily notice that this expression is equal to the distance PA, and this expression is equal to the distance PB. Therefore, fx represents the distance PA plus PB. Now some of you may already know how to find the minimum value of this distance without using calculus. First, we take the symmetric point A prime, whose coordinates are minus 3, minus 2. Then we connect this point A prime with point B with a straight line. Here, let P prime be the point where the line segment A prime B meets the x-axis. Then, since these two lengths are equal, it can be said that we are looking for the minimum value of PA prime plus PB, and it can be easily noticed that this is greater than or equal to length A prime B, which is equal to length P prime A prime plus length P prime B. Therefore, fx is minimum when this point P is located at the position of P prime, that is, when P is on the line segment A prime B. And the minimum value is simply the length of the line segment A prime B, which is square root of the difference between x coordinates, so 4 plus 3 squared, and difference between y coordinates, so 1 plus 2 squared, which gives square root of 58. And at this point, some of you may have already realized how to approach the second problem geometrically as well. Let the given radical expression be fx, y, because it is now a multivariable function depending on both x and y. And now we complete the square again, this time both for x and y. In the first radical, we have x squared minus 4x, so in order to complete the square, we need plus 4. Then for y terms, we have y squared plus 2y, so we need plus 1 to complete the square. Now 4 plus 1 is equal to 5, but since we have 6 as a constant term, we need additional plus 1 at the end. And if we do similarly for the second radical, we have x squared plus 4x, so we add 4. Then we have y squared minus 6y, so we add 9. And in order to make 17, we need plus 4. So, x squared minus 4x plus 4 is equal to x minus 2 squared, and y squared plus 2y plus 1 is equal to y plus 1 squared, and let us write 1 as 1 squared. And as for the second part, we have x plus 2 squared plus y minus 3 squared, and let us write 4 as 2 squared. So now we introduce coordinate axis again, but this time in 3D coordinate space. Here the points are as follows. Point A is 2, minus 1, 1. Point B is minus 2, 3, 2. And point P is x, y, 0, which is the moving point on the xy plane. Then fx, y represents the length PA plus length PB. And now you know what to do. We take this symmetric point A prime with opposite sign for z, which means A prime is 2, minus 1, minus 1. Then we connect A prime and B with a line, which gives this point P prime as the intersection point with the xy plane. Then by the same process as the previous problem, the minimum value of fx, y is given as the length of the line segment A prime B, which corresponds to the case where this P is at the location of intersection point P prime. Therefore, the minimum value is, again, the length of A prime B, which is, for the x coordinate, we have minus 2 squared. For the y coordinate, we have 3 plus 1 squared. And for z coordinates, we have 2 plus 1 squared, which gives square root of 41. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video. And I will see you in another video.